Heino Falke. I'm professor of radio astronomy and astroparticle physics at the Radboud University in Nijmegen in the Netherlands.
My name is Luciano Rezzolla. I am professor of theoretical astrophysics at the Goethe University in Frankfurt.
My name is Michael Kramer. I'm a director at the Max Planck Institute for Radio Astronomy in Bonn.
This project is about taking an image of a black hole.
Black holes have been modeled and they exist in our minds, but an actual picture, an actual photo has never been made.
We not only want to take a picture, but we actually want to understand how the image is formed and whether it's consistent with what we expect from general relativity or other theories of gravity for that matter.
What we want to do essentially is point our telescope there where we think there is a black hole and show that there is a place in its neighborhood where there is no light coming from. This is what is otherwise called the shadow of a black hole.
The problem is, if you want to make an image of a black hole, even the biggest that we have in our Milky Way, it's still a tiny little thing on the sky. It looks like a mustard seed in New York as seen from Bonn. In order to build a telescope that can see this, it has to have the size of the world. What you do is you combine telescopes that are distributed all over the world, and they function as a network. And together, you achieve that resolution.
We want to find a neutron star orbiting the black hole at the same time, and that gives us additional information on the physics of the black hole, and that will complement the image. It will basically check the black hole from two different angles, from the image side and then from the orbital side.
To try and understand whether the image that we produce corresponds to the predictions of Einstein's theory or maybe to something else.
So for this experiment, it was clear that we need expertise from completely different areas. We needed someone with imaging capabilities, we needed someone with numerical relativity capabilities, and in my case, we needed someone who can try to find this additional information via pulsars. And so just being part of this team means you work completely differently.
But suddenly there's this other dimension where you're asked to actually work together with other scientists. And that forces you to think, where am I complementary with someone else? How can we actually help each other? And that is a completely new process. It's not just yourself. It really is having to deal with some very strong and bright people. And they also bring their teams. And then the teams start to interact. They talk and chat with each other. They come up with new ideas. And suddenly the whole is more than the sum of the individuals.
We really need to understand very deeply on a sort of almost day-to-day basis what the other people are doing in order to make progress in our own area. So it's where things really come together, and the Synergy Grant enables you to have this interaction in such an intensive way. You always know someone somewhere at the end of a computer line, at the end of an email, who knows exactly the answer to your question. And so if you don't know the answer, then we work together to find it out.
You have to be able to see what are your talents, but most important, what are the talents of your colleagues. And only if you do that, then I think the synergy really will flourish and the results will come up.
We have all these young people joining us in this endeavor, and it's just great to see all these people sharing this one vision, one goal, and working towards it.
As a scientist, we want to, realize our scientific dreams. We want to answer our questions, and that requires funding. And the ERC gives us actually that possibility.
It really enables the European researchers to be global players, and that's really what we should aspire to.
As it happens, we are as close to get a picture of a black hole as we have ever been. But whether the picture will really tell us that there is a shadow or not, we can't tell yet.
We have our theory, which has tested so far very accurately with other methods. And yes, some expectation is there that the picture should look like this. But nature has always found some ways to surprise us, and indeed, that's when it becomes interesting and exciting.
This is, until now, only a theoretical idea, a prediction. And in science, we always have to verify predictions, and that's what we need to do.
You make a progress if the data don't fit the model. So actually I wouldn't mind to be surprised, because then we have learned something completely new.
For me, synergy means fantastic people.
For me, synergy means more than the sum.
For me, synergy means sharing dreams.